If you're taking a 4-question true-false quiz, how many different ways are there to answer all 4 questions? This may sound familiar because we've dealt with this before. We did it with the tree diagram, I believe, but I want to do it with the fundamental counting principle here and also extend it and ask some more questions about it. So although this looks familiar, we're going to take it a little different route. I want to, instead of doing the tree diagram as I did before, use the fundamental counting principle. Remember, the fundamental counting principle assures us that if we can take a task and break it down to a series of subtasks, and if we can count the number of ways to do each of those subtasks, then we can find the number of ways to do the entire task by multiplication. Now here we're going to be choosing from either true or false, so there are 2 possibilities for each of the 4 questions. So we're looking at how many ways to answer the first question, how many ways we can answer the second question, then the third, then the fourth. And because it's a true-false, there are only 2 ways to answer, 1 and 2 and 3 and 4, and 2 times 2 times 2 times 2 is 16. Just as we got with the tree diagram when we worked it earlier. So there are 16 different ways to do this, to answer a 4-question multiple choice quiz. I want to follow up though and ask some other questions. First of all, how many ways are there to get no questions wrong? If you think about it, we know there's 16 different ways to answer all of them, but how many of those ways would have none wrong? If you think about it, if you think about each branch of the tree as being one possible way you could answer it, if you got none wrong, that means that you answered the same as the key. Think of the instructor as having a key to the test or key to the quiz. There's only one combination of answers that is right. So there's only one way, obviously. One of those 16 branches is the key, and the rest of the 16 are wrong. So there's only one way to get none of the questions wrong. How many ways are there to get one question wrong? And that really means exactly one question wrong, or just one question wrong. A tree diagram might be an easy way to think of it, but think of the responses as already been graded. So if you got a question right, maybe a capital R means you got it right, and an X means you missed it. So if you think of the tree diagram, but instead of T and F, think of right and wrong, R and X. If you think about that same thing, there are 16 ways that you could get graded on that quiz. You either got them all right or got them all wrong, or there are 14 combinations in between where you'd get some right and some wrong. The question is, how many would be giving you just one question wrong? And probably the most straightforward way is just to go down the branches of the tree diagram and find all the branches that just have one X in it. And if you think about it, there's a branch that has just one X in it. If you keep looking, there's another branch that just has one X in it. And you can sort of see the pattern. If you go back to the first one, the first problem got missed and everything else was right. That's X, R, R, R. It means the person got the first one wrong and the rest of them are right. The second one represents missing the second question and getting all the others right. So getting one right, missing 2, and getting 3 and 4 right. And if you follow this pattern, there should be one branch in there where only the third question is wrong. And that's RRXR. And finally, there should be one branch that has just the last question wrong. So that's RRRX. Now, if you think about it, I really did not have to draw the tree diagram, because you can say, I know that I'm dealing with just this. You really don't have to have the tree. I either missed the first one, or I missed the second one, or I missed the third one, or I missed the fourth one. So I sort of claim that you could get that without even drawing the tree. But the tree makes it explicitly clear that that's the case. In any case, there are 4 ways to get exactly one question wrong. Next question. how many ways are there to get 2 questions wrong? Well, if you go back to the analogy to what I just said a minute ago, if I drew a tree diagram and looked for branches that had exactly 1 x, now I'd be looking for a branch that has 2 x's. So you simply scan through there and look for branches that have 2 x's. The first one I see is where you get the first 2 right but miss the last 2. So that's RRXX. If you scan through there, the next one you see that has, if you're moving left to right, the next one you see that has 2 x's is RXRX. Again, moving from left to right, RXXR has 2 x's. Continuing, XRRX has 2 x's, and XRXR has 2 x's, and XXRR has 2 x's. And that's it. So there are 6 ways to get 2 wrong. Now later on, as we learn more counting techniques, we'll be able to get that without quite so much work. But right now, we're just going back to the brute force of using the tree diagram when the question gets too complex. But later on, we'll learn some other ways to do these things. And finally, if you randomly guess at each answer, what are your chances of getting 3 or more correct? Now remember, 3 or more means you either get 3 correct or you get 4 correct. So porting over our strategy from the previous problems, if we look at the tree diagram, those 16 branches, we're looking for branches that have either 3 or 4 R's in them. So if you start left to right and just look, you've got RRRR that has 4. You have RRRX, that's 3. You have RRXR, which has 3. You have RXRR, which has 3. You have XRRR, and that's it. So you have 5 chances out of 16 to get 3 or more correct. I do want to mention, though, that there is a faster way to solve this problem if you realize that we really have already answered the question and just didn't realize it, because when it says getting 3 correct, that's the same as getting 1 wrong, and we had already answered that in an earlier question. And getting 4 correct is the same as getting none wrong, which we'd already answered. So really, if you thought about it, you could just go back and look and see that there were 4 ways that we found of getting 1 wrong, and there was just 1 way of getting none wrong. So you could have gotten 4 plus 1 is 5 without having to go through even scanning, because we had really already solved that problem. It was just asked in terms of being correct instead of being incorrect. But if you notice that, you'd get there a lot quicker.